Alrighty, time to start a new streak. Okay. It is in my medium wheelhouse, maximum path score in a grid. You're given an n by n grid where each cell contains one of the values 0, 1, 2. You're also given integer k. You start from the top left and move to the bottom right, only moving right and down, so can't kind of go backwards. Each cell contributes a score and incurs associated costs according to their cell values. 0 adds 0 to your score and costs 0, 1 adds 1 to your score and costs 1, 2 adds 2 to your score and costs 1. You return the maximum achievable score without exceeding the cost of k, or -1 if no path exists. If you reach that cell but the last total cost exceeds k, the path is invalid. Okay, interesting. This seems like a heap, I want to say. A heap where I'm exploring the positions. So the sorting of the heap is going to be the lowest, the highest current cost. No, the highest. What is the sorting of the list? Heap is going to be sorted by the cost. I'm not sure actually. Is it a heap? Is it just a? Is it a heap or is it just something simpler than that actually? Am I just traversing everything? K is up to what? K is up to 10 to the third. It's a 200 by 200. That's a pretty big K, huh? 200 times 200 is 40,000, 4,000, 40,000, yeah. 40,000, 10 to the third. That is a pretty big grid. I don't think this is dynamic programming. This is a little too big for that. Although it could be wrong. I feel like this is probably heap. Like a heap that has tuples. It's either sorted by K or by score. I'm guessing it's by guessing it's by K. Heap sorted by K. It's a pretty big heap then. K, because you always want to explore the lowest cost. The lowest cost. Lowest cost first. Okay, let's try that. So it'll be, I want to say, tuples of like current K, or cost used, score, or maybe negative score because you want to deal with higher. Heaps, actually, now that I think about it, there is a max heap now, right, in Python? There's sorting of heap push. Heapify transforms the heap queue. Before it was always min heaps, but there's a max heap. Heap push max. Okay, yeah. Yeah, I need to remember to actually use that. But I still want to sort by the lowest score, so lowest K or the lowest cost. So maybe I still need to have a min heap. Okay, I think it's going to be a min heap. Tuples, in that case, I do want to say cost is the first part of the tuple. Then it will be the score. Since I want to be a maximum score first, I'll do negative score and then row and column, something like that. Okay, so, and then probably do, I guess, 0 cost, 0 score, 0 row, 0 column. And then I just need a process. I probably do need to define some simple variables here. Rows, columns is the length of grid, and the length of the first row in the grid is the columns. And then, so it'd be something like, while there is a heap, let's say cost, score, row, column. I guess I'll say this is n score for negative score. Is heap pop. So this will return the smallest, the lowest current score. Hmm. 10 to the third. K can go to 10 to the third. Can I do for every cell a value of k from 0 to 10 to the third? That would make it 10 to the third times 200 times 200. 10 to the third is 1,000, right? Oh, that's a big number. It looks like 40 million. I think I can store that amount. 40 million. What is 40 million? It's 40 megabytes in the worst case. I guess that's probably fine. Grid at ij equals k. What? Wait, so what's this? Grid at ij equals 2. Okay, yeah. I wonder if it should be a heap. Maybe I should just iterate over every single combination. It'd be 200 by 200. So from any position, it'll look at the two neighboring positions that can go to, and then it pushes it onto the stack. And then when I process it, I only process it if it's a current valid one, I guess. Okay, maybe I need to have some sort of storage of the current min. What am I thinking here? What exactly am I thinking here? I think I need to have some sort of storage of like the current low. Is it low cost, or for each cell, for each usage of K up to that cell, the highest score, something like that? So this should be something like maybe the high score up to here is going to be 0. 0 times K for everything in range columns, maybe columns plus 1 for everything in range rows. So for each position in the grid, store the best score up to that position using some number of K, using some amount of costs. I guess that makes sense. I feel like it should be slightly different. An initialization, I mean, ideally, if it's not, the score can only increase. It has to start from 0. So it shouldn't be, obviously, shouldn't be infinity. If it's -1, it might make sense. I guess 0 still makes a lot of sense. -1 would mean that I know that hasn't been done. Then I'm probably going to use the heap to determine what position I'm processing, so the heap is never going to have something that's invalid. Okay, let me double check the sizing here. Making sure my poor syntax doesn't get the best of me. K is, I think this might be K plus 1. So I want to have usage of 0 and 1. Yeah, it should be K plus 1, I think. So for every position, this doesn't look right. There should be 2. There should be a row and there should be a column. I think I need some more bracket. My poor syntax did get the better of me. Should be a 2 by 2 where each element is a 2 zeros. Yep. Okay. Yep. Heap. Okay. So the cost, and then the heap could be out of date, I guess. Yeah, so let me go ahead and just prevent it from doing some out of date shit here. So when it's processing a position, it needs to verify that the current score here is still valid, I guess. I think this is probably better if I did something like this, just to make sure I don't screw up the negatives and positives. So So if the best score at this row and column is already, at this row, column, and amount of k is already better than the current score here, then I need to skip it. If it's equal, then I should probably be processing it. I'm pretty sure. Okay, and then if the best score is bigger, okay, and then the best score should be, can't be smaller at this point, I don't think. But if it's equal, then it's possible that there's a bunch of positions that there's a bunch of ways that get to this position with the same score. I don't want to process it again each time. I don't want to process again each time. I guess best score is bigger, skip. If best score is 0, process. If the best score is smaller, process. If the best score is equal, then skip. Is that right? Is that right? Okay, I think it should be the best score is. I have to assume that the best score is equal at this point. It cannot possibly be smaller. Yeah, it has to be equal at this point. Okay, so if it is equal, then I need to iterate over the adjacent stuff. So apply this to the adjacent paths. Apply this padding. Apply padding to this position to adjacent kind of cells. So if it's not at the last column, the column is less than calls minus, or if call plus 1 is less than calls. Yeah. Then call, so if I can go to the right cell and the best, let me go ahead and just pull up the cost, the current cost for this thing. Current cost and current cost is equal to grid at this row column. And then let's go ahead and create a value for the score. Let's say cost to score is going to be 0, 1, 2. That's not right, is it? It's 0, 1, 2. I guess it's the scores in the grid. Okay. This should be score to cost. And that's 0, 1, 1. Current score is this. And then current cost is equal to score to cost for the current score. I wonder if I should just put it at the top here. I mean, I probably should put it after the continue. Yeah. Okay, so if call plus 1 plus is less than calls and best score for same row, column plus 1. And I guess it'd be k plus, I guess it'd be current costs plus, or cost plus current costs. Cost is the path cost up to now, current cost is the grid cost. The current position in the grid cost. If the, so this would return the highest score if it's a smaller score than the current score. No, it's not current score. It'd be score plus current score. The path score plus the current score. Then best score for the row, column plus 1, cost plus current cost is equal to score plus current score. And then I append this thing to the heap. Heap push onto the heap. It should be the tuple that is cost plus current cost. And then negative of score minus current score because I want to sort by high row column. Might work. Alright, and then if row plus 1 is less than the number of rows, and so just very similar syntax here. Best score of row plus 1 column cost plus current cost less than score plus current score. Best score row plus 1 column cost plus current cost equals score plus current score. Heap push cost plus current cost negative score minus current score. Oh shit, this is the wrong thing, huh? It should be column plus 1. Row plus 1 column. Okay, so that pushes those things. I need to actually identify the ending. So I think right here should be the ending. If the row is equal to rows minus 1 and column is equal to columns minus 1, then return whatever this current score is. And then here return -1. Okay. I wonder if this works. Probably not. Probably fails pretty badly. Well, what's going to happen? So it pushes the first position onto the stack, pops it off or onto the heap, pops it from the heap, checks it's not the ending position, checks that there's something better hasn't been pushed onto the heap. So if there is something better that's been pushed onto the heap, then just ignore it. Identifies the score and cost for this position, and then pushes onto the heap the two adjacent positions based on moving from this position to it, assuming that it's something that causes a higher score to get to that position with that cost. Okay. At this point, I need to actually use K in this, huh? I need to use K in this. Forgot about K. I guess I should do something like, oh yeah, it should just be something like right here. Should be something like, if cost plus current cost is greater than K, continue. Cannot move to adjacent positions if exceeding total cost. So it could be equal to K. I think that's right. I think that's the only time I really need to reference K. Okay, let's go ahead and test it on the test cases. Return outside function. Okay. Fair enough, fair enough. Oh boy. Failing on the first test case. Huh. So I return -1, where obviously I shouldn't return that. K is 1. So it should have gone rightwards. No, it should have gone downwards and then rightwards. How did we not do that? It should have gone downwards, then rightwards. Okay, let's go ahead and print this out each loop. Let's go print heap, I guess. Literally, it's doing no loops. Okay. How interesting. Doing no loops. Is it breaking there? No, it's not breaking there. I guess it's not pushing here. Let's see. It's either, maybe it's one of these. I see. This is zeros. It's not actually exceeding the best score. Yeah, okay. Not exceeding the best score, so it's a bunch of zeros. Should I initialize it to be -1? Guess it has to initialize. Yeah, this is kind of the weird part. I wasn't sure if it should be -1. I think -1 is what needs to happen there. That's the default. Okay, so it's actually getting to the actual code that I have. Heap push. Alright, heap push has a parameter that is the actual heap as the first thing. Whoopsie daisy. Okay, so alright, so I want to actually solving the first one and not, or yeah, solving the first one, not the second now. So this one should return -1. So there shouldn't have been a path here. So 0, 1, 1, 2. How the hell did it get 1? How did it get 1? So first one, it went right and it went down. Or added the right position and the down position. That's fine. And then it would have done this thing next, I want to say. So it would process this thing. So it processed the position at the right. And it should have not added anything. This should have been impossible. I think. I see. I didn't actually incorporate the ending cost. I didn't incorporate the ending cost. How do I want to incorporate the ending cost? So if row, yeah, this is just wrong, isn't it? Because it's gonna find the ending position with the lowest row. It's gonna find the ending position with the lowest cost. Yeah, okay, so this should be something else. Something very, very different. If you're at the ending position, the first time it reaches the ending position, it's the very lowest cost getting there, but it's not necessarily the highest score. Then I think what you want to do is just up. Do you want to do anything? Maybe you should just continue this. Maybe you should just continue this, right? You're at the ending position. Maybe what I want is just actually, let me have an answer array. Yeah, let me have an answer array and then let me go ahead and just append a possible answer append. Okay, if cost plus current cost is less than or equal to k, answer equals max of answer and answer, no, actually, if cost plus current cost is less than or equal to k and score plus current score is greater than answer equals score plus current score, and then continue. Okay, I think that's actually correct logic. Say answer is equal to -1 originally. So if you're at the last position, check if the path to this position has a cost plus the current cost that doesn't exceed k, and the scoring of that would be also higher than the current answer current kind of high score, then in that case, increase the answer. I think that's right. Yeah, okay. And then I just need to return answer at this point. Okay. Let's see how this fares in the greater test set. I think it might be slow. Oh shoot, I forgot to comment this one out. Well, see if that's necessary. Okay, I think it's almost certainly necessary, I think. Was there any more prints? I mean, I don't think I should be this slow, but maybe. 15 seconds, 16 seconds. Please let it mostly be the prints. Oh boy. Okay, apparently it wasn't the prints at all. Oh my god. I didn't even know that it could go this big. Oh my god. Well. Well. What to do here? Am I not supposed to use heaps? How else would I... Is there... How do I... If I didn't use a heap sorted by the lowest cost, how else would I determine which thing to process? Yeah, okay. Should I just be iterating over all the cells? All the cells. Doesn't seem right. Then I have to iterate over all the cells and all the possible k values in the cell. Definitely does not seem right. Is there a way for me to end early? So once I reach the last position, is there a way for me to just say, if I have the last position and the cost plus current cost is less than equal to k. Wonder if I can do something tricky and just like lower k by the last position's cost, and then have that lower bound for the score, or for the overall pathing cost. Like I deduct, I know that I have to actually take the cost of the last cell. So I just remove that cost from the last cell from k. K minus equals the grid at the last position, That's the score value, and then score to cost that. Okay. So K is removed from that. Or K's, so that final cost is removed from K. I mean, it's really only 0, 1, right? But whatever. At that point, there'll be lowest cost here. So I don't really need to worry about if it gets here, it's strictly going to be based on this then. End score plus current score is greater than answer. I still need to continue. Fuck. So if I get to last position and then check its higher score, still not efficient. I mean, I think it's still correct, but it's still not. This is not a speed up. Not at all. I don't think. It's amusing that the removal of the prints actually made it not even correct. Fuck. Index out of range. I wonder if K is less than 0, return -1. So maybe it actually like immediately made it impossible. Let's go ahead and use this test case. Okay, yeah. Forgot about that possibility. Yeah, still. Oh, the mammoth runtimes. Okay, still. Sometimes you are the head, and sometimes you are the tail. There has to be a better way here. I don't even know if it's the optimization of when I exit the code, when I exit the. So I reach the end position. It's going to be based on the lowest cost. I wonder if I should be going by the highest score. I wonder if I should be sorting by the highest score. So that if I reach the end position with the highest score, then obviously I would return it immediately. Maybe that's how I should be determining my pathing. So it's like a max heap then? A max heap? Okay, yeah, okay, let's go ahead and try it. I already tried the min heap. Do I need to keep track of, I think I need to keep track of the cost. The highest score, the lowest cost first. Yeah, I think I need to do highest. So if I use a max heap, sorting by the maximum score possible, I probably want to prioritize or take precedence the lower scoring. or lower costing. Okay, so this should be now score, cost, row column, invert the cost. That's all the same. At this point, I don't think I need to actually, if I get to the final thing with the highest score, is it possible to improve that? Yeah, because it's just one way, and then there could be other ways. I don't know if I'm just ruining my code right now. Okay. I think everything else is the same, to be honest. Everything else is the same. Okay. Oh my god. Break the ship to try to improve it. Oh, fuck. 0, 1, 2, 0. So what happened here was it went this way, it went rightwards and then downwards and then exited. Rather than wait for the downwards pathing. Unfortunate, unfortunate. Okay, let's go and just check the heaping. Print out the heaps. So first processing the original position, it pushed the leftwards and the downwards movement. Then it should have processed the downwards movement next. And it should have gotten a score of 2. No, it processed the left movement first because the score there, yeah. Yeah, okay. So here it's processing 1, 0, I believe. No, it's processing 0, 1 right here. So then it pushed the final position here. Okay, and then because this has a higher score, it processed this thing and it got here. But why would it stop? Why would it stop? So then it should have processed. Okay, we need to actually put more printouts here. So it's processing position 0, 0, the score is 0. Processing position 0, 1 on the first row, score is 0. Processing 1, 0, so on the first column. Then it processed 1, 1, 1. Interesting. Why didn't it cost plus current cost succeeded skip? Processing 1, 1, 1 twice. That's a little weird. Like it should have updated this thing to 2. I think. processing 1 0. Wow, my god, I'm such an idiot. I'm a fucking idiot. I changed the tuple here, but I didn't actually change how I pushed it onto here. I'm so beyond absurd how dumb this is. How dumb my code is, or how dumb I am coding it. Yeah. Just absolutely no thought. Just praying that my code would fix itself. Okay. I think this fixes the incorrect tuples pushed. Okay. That was really bad. Just a lack of brain power. Although, why did it process 111 twice? Oh no, it didn't. It would block it from processing it right here, I think, the second time. Okay, yeah. Alright, maybe this might be faster. We shall see. Okay, actually, maybe this might actually pass the first test. Please pass test cases. Seems like it's still slow. Oh, god damn it. Consart it. Is that actually going to pass the test cases? Doesn't look like it, huh? Oh my god. Oh my lord. Okay. I guess it's time to revert. Revert. Okay, so there was some merit to what I originally did. Not much, but some. So I wonder, could, if I just use a 3D matrix, would it work? 3D matrix, somehow doing a one pass for every position and move to the next position, either from the top. I actually don't think that works out very well if I did a 3D matrix of every possible path to a position, because if I do something like going from 0 0 to 1 1, like left down, or right down versus down right, those could possibly end up in two different points, like, or two different kind of states, considering that the pathing themselves end up with a certain cost in addition to the position. So it just grows so much. So it's like, it literally is 3D in terms of like 40 million, or yeah, 40 million possible kind of endpoints. All right, well, sometimes you are the head and sometimes you are the tail. Tail end I am. Nothing wrong with that. Well, I mean, nothing wrong in my mind for that. Wonder if I could really optimize this ending. Seems really poor. Could I use the first thing that ends up there? Use the first thing that ends up there. I mean, it's sorting by low score. Sorting by low score, highest score. Man, I wonder. I wonder if I can do something like the score plus current score is greater than the answer. And then if, let's say, current costs, if cost plus current costs is equal to k, return the answer. Something like that. Because once it reaches the highest cost allowed, then there shouldn't be any other ways to improve this at that point. I don't think. I don't think there is. Could be very wrong. Willing to be wrong. Also, totally fine if this thing doesn't actually fuck me. How? What? How? So somehow here, within the pathing of this 3x3, I can improve the ants. Okay, let's just use this test case. What is it? What is it? Oh, so is this timing out? No, it's not timing out. It's giving me the wrong answer, right? So output 3 should have been 5. Output 3 should have been 5. The last thing here is 2. Okay, yeah, I kind of see it. So it's like you could still improve it because it's matching this current. It's sorting by cost first, then highest score. Yeah, I see it. Okay. The cost doesn't necessarily. I wonder. Cost first, then highest score. Is there a way to They're better sorting of it. Lowest cost, highest score. So you reach the ending with some low cost, high score. Let's say it's like 5 cost, 10 score, and K is 5. In theory, maybe that's your answer. But maybe there was like a 5 cost. Now how would that work? So you did all your, so if the lowest cost is 5 within your heap, or within this heap, the lowest cost is 3. 3 costs, and then some score reaching the ending position. 3 costs, some score reaching ending position. And somehow that score is improved later on. How would that have worked? How would that have worked? Negative score, so it is high score. It is high score. Okay, let's go and just print out stuff here. Going 0, 0, go right, go down, 0, 2, go right again, middle, left down, middle down, and then so it went here to here to here to here. So it went down, got a point, and then got 2 points. That's a really bad pathing, huh? Because it's getting here with, that's not even K. Cost plus current cost equals K. Like, did that even reach? Did that even reach 3 cost? What's going on here? So yeah, I should have went like 1, 2, 3, 4. Actually, what was the correct pathing here? I should have gone for this 2, this 2, and this 1. So it should have been right, down, down, right, right, down, down, right to get 5. And somehow it just got 3. So it went like down, down, right, right. 2 zeros down, down, then middle, right. So 0, 1, it did process 1, 1. 1, 1 should have pushed 1, 2 and 2, 1 onto the board. And when it did the 2, 1, it should have actually had the high score of 3 at that point. Why did it not? So 1, 1, getting to 1, 1, you should have gotten 3 points, not 2 points. I think. Because you should have gone here for 2 points, and then gone here for 3 points. So 1, 1, your current score is 2. And you should have pushed position 1, 1, 2, no, 2, 1 with a score of 3. Yeah, 2, 1 with a score of 3. 2, 0. Alright, this is too tough for me. I think it's too tough for me to process right now. Should have been 2, 1. 2, 1. Processing 2, 2. 1, 1. Processing 2, 2, 1, 1. Position 2, or position row column 2, cost is 1, or score is 1, score is 1, cost is 1. I shouldn't have returned at that point. Why did it stop there? Why did it stop there? Oh, I see. This should be just this. If current, because I already subtracted the last value from k. If current cost equals, no, if cost equals k, what am I doing? Oh my god. What am I doing? Okay, maybe this works. Something faster, I don't know. It doesn't have to fully empty the heap before returning, which might help. It's still very slow, isn't it? Alright, I'm done. White flag raised. Okay, well, I solved it. I'll say that. Man, what the hell did I do here? Summary. Okay, this is super inefficient code. Although, heaven knows, not me, how to solve it correctly, efficiently. Used a heap to traverse the positions, going or processing the lowest cost with the second priority to, or second ordering by, or second sorting by highest score position. Once it reaches the end position, it can try to return, or it can try to store the score, eventually returning the highest score from that position, from that end position. Yeah, okay. I'll say that also had a matrix that kept the highest score pathing to a particular state, where the state is defined by the cost used, the position, basically a 3D matrix called best score, which is used to limit processing of kind of inferior paths or outdated paths. So whenever I take a path from a particular state and check if I can move to a adjacent position, right or down, then I need to check to see if the scoring of this path to this position to that new place is actually going to improve the scoring that's already there up to that position and with that amount of cost. If so, then push the kind of processing of that state to the heap. Alright, and then there were some other kind of minor improvements leading to a fat nothing, or leading to not much. Alright, time complexity, this is going to be O of n, where n, actually what am I doing here? O of mnk, where the size of grid is m by n, and k is k. Maximum kind of cost. Yeah. This is due to the fact that I'm pretty much searching. Actually, is it? What am I doing here? Is it? Oh, M and K. They're sorting here, so sorting is always n log n. Is it m and k log m and k? God, that's probably why. I mean, if that's it, that's why it's so damn slow. And it's 40 million, log 40 million. Yeah. Because that's the size of the heap is M and K. Okay. Is the maximum cost. The size of the heap should include all possible states, which is M and K, and sorting the heap or insertion of the heap into the heap should be kind of log M and K. So overall should be O log. So overall it should be kind of M and K log M and K. Yeah, I think that's right. Mine's fuzzy. Space is O of M and K, since he can't have that many states. Many tuples slash states. Alright, whatever.